आवाज आ रही है आपको? हाँ, अच्छा, चलो। Bismillahirrahmanirrahim. Honorable invited speakers, faculty members, students, and organization team of ESMoC 2020. It is a one-day international webinar. We welcome you all on this platform. The basic purpose of this webinar was to have discussions on modern challenges of softwares that we are engineering for the modern disciplines and applications. So we have very renowned personalities from all over the world. First of all, I would like to discuss few themes that are the main focus of this webinar. The purpose of this theme was to discuss the prospects, the challenges in engineering the softwares for domain-specific applications, like when we are engineering softwares for security and privacy controls. So then we have to think in another way, and the conventional methods, techniques, and tools now used for conventional software engineering, they sometimes they reach to their limit, and we have to look for other options. And similarly, when we are going to engineer softwares for emergency and disaster situations, or we are engineering softwares that have intelligence and learning ability, and when we are going to engineering softwares for real-time and embedded systems, so we have to face different challenges in these domains. These days, due to COVID-19, we are moving and we are already have moved to the online systems, LMSs, e-learning systems, and blended learning systems. So we need more effective and more easy to use e-learning systems, and so we also need better tools and better techniques for these new domains. Similarly, e-commerce and industry 4.0, and these are the domains where we also need some better techniques, better methods, better models for engineering softwares. So we have been talking about the conventional methods that are being used for we have conventional methods that are being used for modeling software, engineering softwares, testing software, and the rest of the procedures. But we are interested that we talk about these latest issues, and we want to know valuable thoughts of our distinguished speakers and guests. So I would like to name some prestigious names that are with us. We have, first of all, Dr. Dayang from University of Malaysia, and we have Professor Dr. Tatjana Sibilija from Serbia. We have Dr. Taimur Khan from UK, and we also have Professor Nimrata Kaul from Bangalore, India. We have Dr. Pooyan Jamshedi from University of South Carolina, USA. We have Anne from Aberdeen, UK. We have also later in the day we will have Noordin Lokel from Tunisia, and in the evening we will have a very good talk by Dr. Hamad Qureshi from Philips, UK, and Professor Nabil Qadi will also join us from UAE, and then Yasmin Ansari she is from Italy, and Dr. Mahmood from Lyon University, France. So welcome on board. Thank you very much. I request Dr. Rafakat Kazmi to please start with the first talk. Thank you.
Thank you, Dr. Imran Bajwa. Very warm welcome from the team of ESMoC and Islamia University Bahawalpur, all speakers. Now I invite Dr. Professor Dian Noor Hayati from Department of Software Engineering, University Technology, Malaysia, to start her talk.
Let us share the slide first. Rafaka, can I share the slide? Allow me to share my slide.
Yes, madam, sure.
I'm waiting for the host to enable slide sharing.
Yes, ma'am, you can share now.
Okay. Okay, everybody can view my slide, yeah?
Yes, madam, these are visible.
All right. Assalamualaikum and very good morning. I would like to, first of all, I would like to extend my appreciation to organizing team of this webinar today. And then I really like to thank the team for all their hard works to make this webinar happen. So today, I would like to share my view on software engineering education for a changing world, where the software engineering education is the main driver to enable.
Madam, your voice is not coming.
University Technology Malaysia, we have two campuses. We have one campus in Kuala Lumpur, the city of capital city of Malaysia, and then we have another campus in Johor Bahru. I'm here in Johor Bahru. Johor Bahru is our main campus, where Johor Bahru is 1 hour drive from Singapore airport. We have our own airport in Johor. The nearest international airport beside Senai Johor airport, we have Singapore airport, like 1 hour drive from Singapore airport. Okay, this is our main campus in Johor Bahru. I think Rafakat very familiar with this view. And then we have our city campus in Kuala Lumpur. So the two campuses, we have students in Johor Bahru campus, and we also have students in Kuala Lumpur campus. Back to my sharing today, I would like to share two main points. The first one is change in software engineering education. Basically, I would like to look into what are the changes happen in the software world, and then how does software engineering education emerge from the changes. And then the second part of my presentation, I will share with you how we in UTM design our curriculum to really make sure we tally with all the changes. Okay, as far as we know, change always happens. We cannot escape from change. Everything will go through changes. So in software, famous, most people say software changed the world. So meaning that how the software engineering education need to change, because we change the world, software change, and we need to, then software engineering education do change, okay? So this is what I get from ITlogy. Want to change the world, then choose IT. This is what normal people, what we promote to the world, saying that software change the world. So if you want world to change, then software can do so. Okay, this is what we promise. Due to that, I think in terms of software engineering discipline, it's already 50 years of software now. Since 1968, it's been introduced, the term of software engineering. IEEE Software Magazine, in their issue October 2018, discussed detail on this 50th anniversary of software engineering discipline. There are 6 issues discussed by the editor. The first one is software controlling the social activity of the world. The second is software innovator remember when no school for it even exists, meaning that how we start from zero software engineering knowledge or minimum software engineering knowledge, and how we help in developing software engineer in solving the changing world situation. And then Agile goes mainstream, and then there are many more development in software engineering nature. Okay, I just tried to look at a few articles from the magazine. The first article addressed how we as a software engineer or software engineer design the software, develop a software, and learn from the software development starting from 1968 in order to develop a future system. So what we can see here is a basic, very primitive modeling that we have in early of 1968 software development. Okay, so we started from this, but we do develop and we do change our discipline, okay, towards what we have now in developing software. This is one example how Agile evolved, where in late 90s, we start introducing a number of software reusability technique, a few methods for software development, and mid 2000, we start to look into security and global SE and more critical system, embedded system. And then late 2000, we'll start looking into CMMI discipline, and then product line, DevOps, and then up to now, we looking into AI and Internet of Things, clouds, and many more, which related to 4.0. This is how software engineering or software discipline evolve within from years to years. When we look into software engineering, CMU, Carnegie Mellon University addressed a number of challenges in software engineering education. Okay, among the issue or among the challenge addressed by Carnegie Mellon University revise the curricula to address current needs. What are the current needs of the software engineer? We need to address it in our software engineering curriculum. And then find way to reach practitioners who entering the field, because we have 2 groups of practitioners who entering the software engineering field. One group, those from the field who have a proper background of software engineering education, and another group without proper engineering education might be their background from different domain, like for example, from other engineering domain or from medical domain, and they start developing software. Okay, so it is our responsibility as an educator to share our knowledge of software engineering to this group of ad hoc background who join our field. And then work with educator in other field, like for example, our colleague from different faculty try to introduce software engineering discipline to their curriculum. Fourth is infuse engineering attitude and technique in undergraduate program. I will discuss a lot of this in my example later. And then incorporate social ethics and policy implementation of computing technology in curriculum. Okay, when we talk about change, it really drives innovation. Because usually when we say change, it leads to, we need to learn something, because changing requires us to learn and then require us to innovate, okay? Let's have a look how world change. World change, and as I mentioned just now, software start managing the world. We use software to change the world. So world is changing. Due to that, the requirement or the, we need to create evolution in software engineering education, meaning that we need to create more innovative way of teaching software engineer in order for them to innovate more software products. So this cycle will need to go on and go on, will change. We need much more innovative products, then we need to retrain software engineer. These are the circles of change, software and software engineering. When we're talking about change, there are different classification of change. So we are much more interested with disruptive change, which change will lead to destructive. Okay, this group of change. So most people talking about 4IR, Fourth Industrial Revolution, as a disruptive change happen in all fields, okay? Where the Industry 4.0 very much focused with cyber physical system. When we look into the emerging technology which leads to 4IR, okay, there are many computer software engineering fields that we need to focus here, like for example, cloud computing, Internet of Things, cybersecurity, big data, and then there are many more other disciplines which integrate with software engineering, like for example, mobile robot integrate with software engineering, the system integration and things, many more, okay? So in our domain, in software engineering, Agile is very much stated as the way to respond to change. Okay, agility is ability to create and respond to change. So Agile's not only been used in software development, it's also been used in construction, it's also been used in different fields of development. So for me, I believe agility in curriculum design, in software engineering curriculum design is reasonable to innovate in software engineering education. I will discuss further on this, how we manage that. Okay, let's focus with software engineering. There are many guidelines available. For example, we have SWABOK, software engineering body of knowledge. We have guideline for undergraduate. We have guideline for postgraduate. Like in Malaysia, we have computing standard guideline by our ministry, where one of the field focus in this standard is also software engineering. So when we look into software engineering related research work, worldwide people looking at the techniques and or methods for teaching and learning to enhance the practical experience of the students in classroom or in our curriculum. So there are more number of innovative methods, number of experience sharing happen here in this research. For example, what I listed here. Another view of software engineering research is looking into the culture, how culture differ different culture, different region will lead to different software engineering discipline. Even though we have a standard software engineering discipline where all software engineers need to really base on the principle of it. There are also researchers looking into how technology can help in software engineering education. Like for example, how MOOC, massive open learning course in software engineering education, how gamification can be used in software engineering education and things like that. These are the development of software engineering research worldwide. If we look into industry point of view, okay, industry point of view, for example, Microsoft start looking into the future ready skill. What are the skill sets that should we integrate with our curriculum or with our students so that they were ready for job market, okay? These are the direction now. Like for example, this talk in November, Microsoft start talking about future ready skill in computer science. Due to that, Malaysia, we have our own frameworks where we're also looking at future ready curriculum for Malaysian high education high education curriculum. Okay, based on that, we in University Technology Malaysia, we call it UTM, design our own future ready curriculum guideline in 2019, where we have this book who lined up what are the guidelines when we want to develop curriculum in UTM. But in this talk, I will focus with software engineering based curriculum. So the UTM future ready curriculum based on three things, which is transformative structure, convergence of discipline, 4IR, different IoT and things like that, innovative delivery, okay, create meaningful immersive experience learning for students, and then assessment, which is we are looking at more holistic assessment rather than only conventional assessment. So again, agility help in designing, delivery, and assessment of a curriculum structure. Okay. Next, I will discuss with you how we implement these three direction into our computing curriculum in our campus. Okay. Our academic program, we have 5 undergraduate program, and then we have 8 postgraduate program. And then the focus of my talk today is Bachelor of Software Engineering and Bachelor of Data Engineering. Overall, for undergraduate, we have around 1,330 students in campus for undergraduate in computing. And then we have postgraduate around 486 students for postgraduate in all programs. And for postgraduate, we also have MPhil in software engineering and PhD in software engineering. Okay, first we want to integrate 21st century skill into our undergraduate computing curriculum. Okay, we highlighted a number of attributes or checklists where we need to integrate to our curriculum. Like for example, we need to integrate graduate attributes, constructive alignment, third language, work-based learning, and service learning. I will discuss further how we integrate capstone and cornerstone multidisciplinary courses into our curriculum. Okay. So as I mentioned, I will discuss 2 versions of curriculum. The first version of the mode of the curriculum, we call it 2U2I. I will discuss further what is 2U2I. As I mentioned here, our data engineering program is a 2U2I modes program, and the rest, the other 4 are conventional program. Okay. So 2U2I program integrate where our student will be 2 years in university. The 3rd years they release to industry, And the final years is block release to industry, meaning that the whole 1 year will be with the industry. So Malaysia government defined one guideline, we call it 2U2I study mode, where allow a student to be with industry minimum 1 year, can be more than 1 year, 1 to 2 years. Okay, that is one mode of study. Another mode is conventional, where our software engineering, Bachelor of Software Engineering program is here, where we integrate all the 4 IR elements just now, like service learning, capstone, move the WBL into the curriculum design. Okay. Next is, that is the design of the curriculum, how we control the delivery of the content of the courses in our curriculum. In UTM, we have a guideline called New Academia Learning Innovation, which really help and give us a guideline how to design courses in the program or in the curriculum. So what we integrate into the courses like industrial visit, problem-based learning, project-based learning, hands-on prototyping development, community-based projects, and service learning. These are among the activity that we integrate into our curriculum. So I will discuss further how we integrate work-based learning in our curriculum. Okay, work-based learning, there are a number of methods to implement work-based learning. The first one is work-directed theoretical learning, where we integrate it in classroom-based, tutorial-based, okay? We call it work-directed. The second one is problem-based, where we bring the problem to classroom. And the third one is project-based, where we bring the real project to our classroom. And then workplace learning, where we have our student and they need to be in the workspace in certain block release so that they can learn from the curriculum. So I will further give example based on these two programs, our Bachelor of Software Engineering and Bachelor of Data Engineering program. I will discuss how we implement work-directed theoretical learning here, and then how we implement project-based learning here with this course, and then collaborative problem-based learning with software engineering and requirement engineering courses, and then collaborative project-based learning with 3 more courses, and then our integral industrial integrated project as workplace learning. Okay, the first case study is our course. We call it Technology and Information System. This course is a cornerstone course, which is a year 1 course, where we implement active learning, project-based learning, industrial visit, and lab work in this course. Okay, where we outline the activity where the student need to visit industry. The student visit more than 1 industry, and then they're not to do reflection with the industry. And then beside the student going to the industry, we also invite industry to come to our campus and give talk to our student. This is basically a cornerstone where really give an overall view how software engineer will work in a real world job market. Okay, so these are the example how we outline the course structure. Okay, these are among the activity. They visited industry or things like that. So the assessment is the student visited at least 3 industry in 1 course, and then there will be public lecture from industry, and then all these industry visits and talk will be reflected by the student in their e-portfolio. So the evaluation of this program mostly on the reflection, how the student view industry scenario from their point of view of first year student. This is one course. The second course that I would like to share is application development. This application development is a capstone course, okay? It is a service learning process, service learning delivery, where the student need to solve community problem, where they need to go out to community, outreach to community, and try to find community problem and solve. This course is for third year students. So third year student, they already went through year 1 and year 2, so that they can apply many experience that they went through in year 1 and year 2 skill into this capstone project. Yeah? And then the targeted community, either community in UTM or other community near the university, where they find the problem, develop software, or develop solution which can help or solve community problem. Okay, then where this is example where our students sit with community, try to find their problem and try to solve their problem. In this project, because it is a group project, like 6 students in a group, we really emphasize on agile development, where they can practice or train the student to communicate, to working as a software team and respond to change during this, the software development process. Okay, at the end, they will need to showcase their product to the community. And then if the community like the product, then the community can freely use the product, okay? The third case study is a collaborative project for 2 courses, which is software engineering course and requirement engineering and software modeling course. Here we implement project collaboration. What I mean by project collaboration is using one project in different courses. Like for example, the student in the same semester register for these 2 courses, which is requirement engineering and software engineering. Then they will share the same one project. Okay, then we call it collaboration project. In order to plan this collaboration project, we need to make the 2 courses synchronized in terms of their project and what we're going to assess. Like for example, software engineering has its own course learning objective or outcome, and requirement engineering course have its own course learning outcome. But somewhere, both lecturers need to sit and really figure out how to synchronize the activities of these 2 courses. Because the student only will use this project, example, this one project in 2017, we use, they developed dengue vector control, and in 2018, they developed knowledge portal. So these 2 courses need to really plan what are the activity for requirement engineering, what are the activity for software engineering, using this only one project, okay? And then the same thing with the deliverables or the milestone for each courses. But only one project, both courses will be assessed that project looking at their attribute or their skill that they want to evaluate or assess. So these are the activity, design thinking, problem solving, team discussion, and again, at the end of the class, the student need to demo and pinch the activity with the stakeholder. Okay, that is one, we call it problem-based collaborative project. The case study number 4, we collaboratively share 3 courses in one project for 3 courses. So in this case study, we use the 3 courses are database, system analysis and design, and system technology, system development technology, where there are in year 2 students and they're registered for many more courses, but the courses that we integrate 1, 2, 3 courses. So they will solve one industry problem, because this is 2U2I program. they really need to solve a real industry project, where the student need to conduct work-based learning, where they need to have work-based day release. Like for example, in one semester planning, they will be with industry to sit with industry and solve the industry problem. Like for example, this design, 30% of the course content will be based on work-based learning, meaning that in week 7, week 9, week 13, they will be with industry. They will sit with industry, solve the problem using all the topic that we discuss with them, or the skill that we want them to integrate in the project, okay? So this is example of, so just now we have 3 courses, then we need to integrate and design this to create 3 courses based on one industry project. This is example where at the beginning of the semester, we need to match the industry with the group of students, okay? And then the student will solve the industry problem by going to the industry and sit with the industry for a few weeks of the semester. Yeah. Okay, my last case study sharing is workplace learning. This is only this is true for our 2U2I program, where we have data engineering student. This is happen in the final year of the student, where the student need to sit and work with industry for 1 year. We call it workplace learning. Workplace learning is slightly different with practical training, because practical training, our collaboration with industry is slightly loose, where we just assign student to industry, and industry will be, the student will be with industry, and we mostly evaluate their report and technical and generic skill. But for workplace learning, there will be partnership or agreement between industry and university, where we really want the industry to assist us in teaching the student. So for example, this is our design for final year student of that design, where 2 semesters, the student will be with the industry, and then all the courses like 14 credit and 12 credit will be assessed both industry and the university together. Okay, so we call it block release. Okay, so from example that I discussed just now, we can see that our world is changing. Software training is very important to enable the world change. So meaning that the curriculum development and revision need to be done consistently and need to be managed and changed across the curriculum life cycle. As long as the program, the academics program is still available, we really need to manage the change in the curriculum life cycle. So for me, software engineering discipline like Agile can be used in managing curriculum development, where agility of the curriculum, we need to rapidly change to make sure we can have an innovative way of developing software engineer, and to have a sustainable academic program. And then we need to incrementally develop the program, because we cannot do it at one shot, because change happen every time, now and then. And then definitely we cannot start it from scratch. We need to reuse something that already there. And then the design of the curriculum need to be bottom up and top down design. So with that remark, I would like to end my presentation. Thank you very much.
Thank you very much, Dr. Dayan Nurhayati. Any participants, if have any questions to Dr. Dayan, can you please ask your question? Hi, Dr. Imran here. Being you are an expert of software engineering, I have one question for you. What are your uh, expectations that the modern e-learning requirements and the e-learning softwares like LMS, so how the current software engineering models and techniques are, do you think they are sufficient or we need some improvement in, please also guide in what aspect they are required?
Okay, thank you, Dr. Imran, for the question. This is a new normal for us, I think, worldwide. As an academician and as a student, we together going through a quite drastic change after this COVID-19, where all the lecturer, all the students need to conduct their teaching and learning process online, okay? And then I know it is not easy for both sides, which is the student side and the lecture side, to really design a desirable or the best way of teaching and learning using e-learning, okay? But we need to innovate, we need to plan, we need to really experience and improve from the process that we went through, okay? This is my belief. If you want to ask, is it enough technology or is it enough e-learning platforms or provided by e-learning platform to support this learning? It's very subjective depending on the courses that we offer, right? If we offer something that hands-on, we offer something that we need to think of more innovative way of delivering things to students. If you ask me, is it enough or it is a challenging way of delivering things online. But is it enough? Not to the point of certain type of courses. There are courses like courses with 100% lecture without hands-on would be appropriate for only use e-learning. But there are courses which really need us to be more innovative in teaching and learning. I hope that answers your question, Dr. Imran.
Thank you very much. Thank you very much, Dr. Dayan. Nice talk. Now I request Dr. Humeda Tariq to please start your talk and please share your screen.
So, can you hear me on? Can you all hear me? Assalamu alaikum.
Yes, we are hearing that.
Thank you so much. So, should I share my screen?
Yes, yes, sure. Yes, it is shared. You please start.
Now you can see my slides, I hope.
Yes, these are visible.
Right. So I would like to start with the name of Allah. Bismillahir Rahmanir Rahim. In the name of Allah, the most beneficial, ever merciful. Obviously, first I would like to take a moment to thank all the organizers, technical staff, professors, chairs, and top of all, program chair, Prof. Dr. Imran Sarwar Bajwa, who contacted me and provide me opportunity to listen the experts from all over the world. And I really appreciate this effort in the days of pandemic. Thank you so much, Dr. Imran, Dr. Rafaqat, thank you so much. So the theme when I saw is the engineering softwares for the modern challenges. So these days I am working on biometrics, but I think I should start with a little background of machine learning and then moves towards the biometrics. So I set the theme, the specific theme is machine learning and the biometrics for today's lecture. So here is the agenda, that how the, what is the current trend in artificial intelligence, what are the international standards, and what are standard biometric system, and how all this end up with the deep networks. But on top of that, I would like to discuss few interesting applications of artificial intelligence and machine learning. And then I will end up at biometric systems. So these are few buzzwords and big bangs, which all of us hearing these days. Everybody wants to do artificial intelligence these days. Everybody is saying that I am a data scientist and I am doing machine learning. And everybody is literally crazy about the deep learning. So it is very important to discriminate between these buzzwords and to know the big bangs. So basically, what the deep learning does for the developers is they automate the feature extraction part. Before deep learning, the programmers have to write own code and which is very extensive and which is not generalized to extract the features for recognition, classification. But the deep learning not only automate the feature extraction process, but it also provides it in the form of hardware and devices at the consumer market and at our doorstep. Now we can put a device at our gate to stop the burglary. We can stop the thieves from coming in our house. And before the artificial intelligence is basically the classical concept in which we don't have when we don't have the big data, we don't have such a big data from Facebook, Twitter, and social media. We don't have the GPUs. So the three big bangs of these days are big data, graphical processing unit, which is GPU. So I hope I help you to clear these three buzzwords. So artificial intelligence is the classical artificial intelligence, which we are doing before 90s. Between 90s and 2010, what we are doing is machine learning. And after 2010, the people, what we all see is basically deep learning. So before moving further on, I would like to share the quote of a Maulana Rumi, which I personally follow in my professional career, that don't be satisfied with the stories. We always heard that that India is doing this and USA is doing this and UK is doing this. But personally, I follow my own way and unfold these myths with my own examples. So this is the same message for you, that we should not think that where we are standing, we should start traveling and we will definitely get some way to move forward. So he truly said that don't be satisfied with the stories. How things have gone with others, it is not necessary that it also happens with you. So unfold your own way. Thank you, Maulana Rumi. So this is my first sample work. So which I would like to share with all the MS PhD students, especially, which is the fog removal. So this is I started this work in 2017 or I think 16 with my students who are now doing PhD in foreign. So this is a dehazing and assessment method. You can see that there is a foggy image on the left side, and after applying machine learning or deep learning, the image becomes clear. And this is not just for fun. We all know that the world is facing climate change. And if you see the China, if you see the Bangladesh, if you see Philippines, and if you see Pakistan, so all the problems are common, which is the pollution, and the world is looking for a solution. And I am sure that the time is not far away when we have a camera and we have this technology in our cell phones, then we are taking an image and we can remove the fog from it. So this is the mathematical model. This is the challenge. Our students have to understand, our academia has to understand that the back-end physics and the back-end mathematics is basically the key. So this is how all the physics is there, that a camera is capturing a foggy image, a hazy image, and with that image there are the pollutants or the haze or the sunlight which are mixing with it. So we have to reconstruct the model to create the natural scene. These are some results. These are our results basically. So when we provide this stadium foggy image, you can see the recovered image is free of fog, but then the colors become saturated. So even after recovery, you need to apply some post-processing steps to give a natural look to the picture. Similarly, you can see a forest with a lot of haze in it, and you can see a clear path over here. The inspiration of this work is the incident of the army in the army school in Pakistan, in which lot of child have been I got tears in my eyes with the remembrance of that day. So this is the sample work too, which is basically the what I observed that we have a very different culture. If you look at the Western clothes, so these are mostly plain and solid in color. But when we look at our audience, we usually wear printed designs, and our gents wear the plain designs. So this is another sample work which I especially would like to share because it belongs to our culture. It's the pattern extraction from branded cloth, and we apply Hog, histogram of gradient, and support vector machine on this. This is already published, and you can see that we have implement a software in which we trained the person detector on our images, which could be any fashion designing. And we loaded, we can detect it, we can show the wrong regions. This is the correct detection of a person, and there is another red window which shows the false detection. So when we want to remove these false detections, we have to apply negative hard mining, which we basically experience in this project. So this is the whole flow chart, that we have a database of images which contains both positive samples and negative samples. Gradient computation is always plays a very important role. And then you have a feature extraction stage. Then you need to provide labeling and annotation. You have to apply a certain classification. You have to train a model, and if your model is not well trained, then you have to retrain it again by providing the hard negative test. And finally, when the training is done, you can end it and use that model for any real life use cases. So this is how the system works. uh, uh, as a third sample work, as my research areas, you can see are image processing, biomedical imaging, computer graphics, and I am doing it since last 15 years as a part of professor at University of Karachi. So this is my PhD work in which I explore the volumetric images, brain MR images, and done its classification. And again, I found that it is very not interesting. In fact, it is compulsory that our people should work in healthcare sector, because such healthcare softwares are very expensive. And I believe that we can easily implement it at academia level in universities and in our labs. So you can see that there are 4 major classes in the brain MR images. One is the background, which is represented by the gray color over here. Then we have a cerebrospinal fluid, which is marked with the blue. This is the gray matter, which is the light blue area, and this is the white matter. This classification is very important because if we didn't, please note one another difference between the input images and the output images. In the input image, we can see a skull around this brain. So a very different of this outer skull. So you can see there is no skull around the brain. And without it, you cannot do any further processing. These are the usually one runs from. Can you hear me?
Yes, madam, we are hearing. Please share.
Oh, sorry, I think there is a connection break for a moment. So I need to, I think, can you see my screen, or I have to reshare it again?
You can share your slides again, and we are hearing you. Your voice is clear.
Okay.
Yes, your slides are visible. You can please start.
So this is another piece of work. This is the software which I develop on my own, in which I simply started with the idea that all the mothers and the women in our houses are offering prayers by sitting. So mostly they have their knee problems in which the gap is reduced. So I apply the basic mathematics and image processing to measure the gap between the knees and to grade that at what grading of osteoarthritis we can assign to these images, so that the medical imaging can be reporting can be done automated. We can see that from the remote areas, so many people are coming to the urban areas only for testing purpose. So if somehow we can provide this service to the rural areas people, I think it's a big achievement. So now moving on towards the other evolving trend which I am looking at these days, is obviously the agricultural industry, in which we analyze the farm data. The automobile industry, obviously soon we will see the smart cars. The retailer and shopping industry, Amazon, Alibaba is one of the example. The home automation, everybody wants to make its home smart. Everybody wants personalization, so social media is another area. The game industry, in which the opponent is an AI agent. The navigation industry, all of us are traveling with Uber these days, so it's a GPS area. The healthcare industry, in which robots will perform surgeries in future, either alone or with the doctors. But on top of it, I wrote it in the last, but creativity and innovation, movies. So the next example is very interesting, that it's time when you can see the fake actors, fake audios, fake political advertisements, bullying, and you are going to face massive problems for evidence collection. Because if you say this is Barack Obama, in fact it is not. You can see the text. This entire speech and video are not real. So all the videos on the YouTube, you will find a lot of videos with the name deepfake technology. And in deepfake technology, what the developers does, they use the existing photos and the existing videos of any celebrity or any person, and they can synthesize the fake videos. So basically it's the computer model of a person that looks, talk or acts just like a target actor. And here is a news from a defense department of USA that in 2018 they have developed the first tool for catching deep fakes. So yes, I didn't believe on the videos and whatever the data floating on our social media, because we don't know which one is true and which one is false. So now from deep fake, now moving towards my main topic, which is biometric, which is another top trend in these days. And its use cases are that you need cryptographic seals on every devices, on every drug, so that to make sure that they are not editable. And you can make sure, a consumer or a customer can make sure that the video he is looking at is the original video, the photo he is looking at is the original photo, and the drug he is using is the original drug. So biometric can be divided into two classes. One is well-controlled environment and the other is uncontrolled environment. And you need, with the facial recognition softwares, you need liveness detection, because if a person put a photo in front of the software, then how you can recognize that this is the same person or the photo. So this is another live area. And even with a photo, the person wear a mask of the another person, so the related area is behavior recognition. And soon we will have interactive ID cards which can interact with the system. But with all this technology improvement, we need strong ethical frameworks to handle privacy and regulatory issues. So here is the some takeaways reported by the University of Texas, that the fingerprints are the most common technology, and mobile devices is the fast growing area. And the market sector which uses biometric is obviously the information technology, finance, and the government is looking at it. And all the military persons also use this biometric for evidence collection and to judge between the truthness and the falseness of the things. So it is very important to know the standard. So if we look at the market trend, we can see that in market, we have vein recognition, we have iris recognition, we have face recognition, we have fingerprint recognition. And you can see that the major area, which is in green, is occupied by the fingerprint recognition. And the second growing area is now face recognition, because the Apple and the Samsung has provided this recognition technology into their devices, latest devices. And so until 2024, you can see the face recognition is going to capture the market, which the market analyzer are seeing at it. And this is the market worth. It varies between 19 billion to 24 billion as per my research, which I did last night. So this is the ABI research. And you can also see the survey with respect to the sectors or the real world use cases that it is required in education, retail industry, finance, government, hotels and food services, telecommunication, transportation, construction. So it's a very, very rapidly growing area, biometric. Why you need biometrics? Because everybody is traveling, and we see that traveling is the security is needs demand growing day by day. So whether it is physical mobility, whether it is logical mobility, whether it is digital mobility, you need to automate the border control, because there is a lot of queues at the airport for the baggage control, for taking the boarding cards, and for scrutiny purpose. So you need ultimately e-gates at all the airports of the world. You need automated passports. You need next generation to secure your documents. So biometric is not limited to the face recognition. It is expanded in all the dimensions. So you can see the statement by the US Department after 11 September that in a world where security is a constant concern, and obviously in Pakistan it is as well, you have to make the identity of individuals, and you have to keep the record to make that everything is correct. But I want to draw your attention towards one thing, that US is and this department is working over 40 years. It's been 40 years that the peoples and their departments, their national security department are working on these technologies. And that's why at their airports, there is no queue for the people. The people just stand in front of the device, which did all the biometric, and the queuing time reduces a lot. And it's a good news that our government is also looking in this direction, and our most Ministry of Science and Technology also trying to set up standards and quality control over here under the Act 6 of 1996. So it's the Pakistan Standards and Quality Control Authority, PSQCA, which is looking into all these methods for standing up standards, testing and assessments, standardization improvement. And on top of that, coordination and cooperation with all the national, regional, and international organizations which are working on the standards. So I took this diagram from, you can say, ISO standard. So this is one of the suggestions that whenever we are going to implement a system, we can take guidance from the ISO standards, which are free and which are choice, which are not compulsory. So they will give you a complete picture that how this system works, so that any country or any organization can adopt it. So we can see its subcomponents, where we have a data capture subsystem, we have a signal processing subsystem, and we have a decision-making subsystem. So the left side is basically the input side, right? And the right side is basically the decision-making or output side, where you can see the two types of outcomes came. One is verification outcome and other is the identification outcome. There is a slight difference between verification and identification, which I will make clear in the next slide. You can see matching, which is simply if-else statement, that if the score appears to be similar of two different faces, then it goes for verification and identification. Before matching, you can see a template is traveling between the data storage and the matching component. So what the developer does, this is the consumer end. But before the consumer, this is what the software developer does. They have to prepare this data storage, this enrollment database. And this enrollment database captures the templates. And the template creation requires the whole image processing and quality control techniques so that these scores will give best results. And obviously, this data storage requires some device, some sensor to capture the samples. So this is the building blocks of a generic biometric system which have been followed from ISO standards. And the ISO standards work in collaboration with international electrotechnical commissions, and Pakistan most take these standards and try to implement it in our country as well with organizations. So we can see that there are three main processes: enrollment, verification, and identification. And enrollment is the most tedious among them. And I just break down this diagram that if somebody does not realize it at once, he can see a breakup diagram. This is the input side, that there is a sensor, just like we go for our fingerprints thumb through our device. So we need a sensor and a presentation layer to capture the biometric characteristics. We have to prepare the database. We have to send all captured biometric samples for feature extraction, for quality control, prepare the template and store them in the database for further verification and identification. Here you can see the breakup between the enrollment process and the authentication process. So in an enrollment process, what the modification that instead of 2D images, you can also use the 3D images of the image. Again, you can pre-process them, you can resample them, you can extract the features, you can do more, you can add more parameters like watermarking, and then you can prepare a more enriched database. And here, the same, you need to determine in the authentication process if somebody tried to tamper, yes or no, and on the basis of this decision, you can end up your process. So these are all the concepts that you have to strengthen if you want to build such softwares. Then you must have a strong image space concepts, that how to enhance a bad quality image. You must have a feature space concepts, that how to extract all the features. You must have make a quality check before storage and identification. And once you have created the references, you can use them with your smart cards or local server or the central database. So here I would like to state the verification. For verification, a single specific claim of a subject would lead to a single comparison score. So verification means a single entity. And these comparison scores basically obviously indicate the similarity or dissimilarities between the features and the references compared. And in technical terms, they are called, the subject which you are presenting for verification are called probes. And with which you are trying to match it are called references. So this is all these technical terms are available in the ISO standard documents, and anyone can use it to build its own system. Here is for identification, you can compare against each of the template or reference which you stored in the database. So this is the decision system. The two main components of the decision system are verification or identification, as I already told you. In case of verification, the features are considered to match a compared reference. And in the case of identification, the enrollee reference is a potential candidate for the subject. And here you apply a specified threshold. In both cases, you may allow or require multiple attempts. So here are the final section, that what the buzzwords which I initiated with the deep networks, and I told you that all the things are moving toward deep networks, and the reason for its success is that they are now available in the form of hardware devices when anyone can use to whether it is automobile industry, whether it is agricultural industry, whether it is Hollywood film making. So the deep networks are now in the consumer market. This is the hardware, and this is the thing that now we need GPU. We all need to upgrade our labs, the academia especially, because in public sector universities we have all the PCs with which are CPU based, so a very limited people's are. But HEC working on it and establishing high computing labs for us. So hope for the best. So this is how the problem looks like in a deep network environment. It depends that you are dealing with a uniform sample size or a non-uniform sample size. You are working on a uni-class problem or you are working with a multi-class problem. But usually the face recognition is a multi-label classification problem, and you are supposed to work in a high dimensional feature space. So here we can see this is a celebrity database which I recently worked on. So every celebrity, for example, if this is a Tom Cruise, so all the Tom Cruise images will make up the cluster number 1. And if this is Levitt, then all the images makes another cluster. If this is George W. Bush, it makes another cluster. So basically you require a lot of images of a single subject if you are interested in face recognition. And you are supposed to treat the cluster as a vector. You can see I draw a vector from this cluster till the origin. So, and this is that's why the linear algebra and the computational linear algebra and the matrices are very important. So these are few historical milestones. The very first technical report was launched in 1966. And the first PhD thesis on face recognition was written in 1973. And there is, you can see a fast development, 73 and 90. So it's 2 years, 20 years. Almost after 20 years, we heard the concept of Eigen Faces, which you can see the goose-like faces. And it's simply the average. If I take the images of all the participants and I mix them, I shake them, I take the average of them, I can get this Eigen Faces. And after Eigen Faces, there is another improvement in terms of Fisher faces, and there is only 91 and 97. Again, it takes 6 years. So whatever we are seeing is not happening in days or in weeks or in months. It took years. So this is the one of the most famous face detector, Viola and Jones, which every student or every researcher is using these days, Viola and Jones. And this is the famous Lena. And I'm always amazed to see this image. Everywhere it occurs, Lena. So Viola and Jones face detector is a very popular face detector, which you can, and after 5 years, we see local binary patterns in 2006. And again, almost after 3 years, we see the sparse representation of the face, which look like this in 2009. And after 2009, you can see after 2009, which is just after LBP, we have a drastic change. We are getting 2014, 2015, 2016, 2017, 2018, 2019. So people are working at a very fast pace on these technologies, and every day we are facing the bombardment of the new networks. So once again, if I go backward, there is a sparse representation, there is linear binary pattern, there is Gabor feature, there are Fisher faces, there are Eigen faces. But today, we are facing the deep, we are seeing and experiencing the deep networks, the deep faces, the deep IDs, the VGG network, the face network, the Bedu network, the effective face network, the sphere face, the arc face. and we are standing in 2020. This is the timeline till 2019. So everybody who wants to work on latest, he has to start with this arc faces or sphere faces to explore biometric recognition. These are again some of the famous networks which you can easily, its code is easily available on the GitHub and all the research platforms. LeNet, AlexNet, Google LeNet, ResNet, DenseNet. It is Squeeze, and I forgot this, but this is another network, and this is DLA. I have, if I skip, I noted this is Squeeze and Excitation Network. SCNet stands for Squeeze and Excitation Network, while the DLA stands for, these are the basically accelerated, deep learning accelerated SDK. So this is where we have, our generation have to start at this point. So the technology is running very, very fast. And if we didn't make our pace fast, we will left behind as before. This is another improvement. Soft biometrics is another new area in which you can see that the camera is capturing a person. It is a side view of a person, and it is very difficult to look recognized by his face. So there is a huge mapping that what type of headwear it wears, what is the hair color, what is the hair length, what is the skin color. So soft biometrics is another branch of identity science which use visual cues to identify people, and it is mainly for the distant cameras. And it is the most important part of it that it is invariant to angle and pose. Whatever pose you have, it is not necessarily that you have the front face, which is the controlled environment feature. And why face recognition is difficult? So number one, intra-class variability. If you can see this subject, all the 6 faces belong to the same class, but here due to lighting and illumination, the face looks different. Here due to pose, it looks different.
Madam, time is short. So
okay, I am finishing it. So face recognition is difficult. This is again just the representation of Fisher and Eigen faces. These are linear binary pattern faces, and this is how the deep network works. You can take an input image, you can identify the landmarks, you convolve it with the input image, and you pass them through a block of convolutional layers, and you encode it to produce the identification and verification. This is the last slide where I put up the recognition results till 2019, and you can see from 1991, if you go in 2019, which you are dealing with arc face and combined those, it's 99% accurate. In 1991, it's 60% accuracy, and in 2019, it's 99% accuracy. So this is how the technology works, and this is why we need to work on these softwares. This is the national requirement of our nation. In the end, I would like to end with this, that despite these recent progresses, the problem of human or human-like intelligence is not solved, not as a scientific problem, not as an engineering problem. You need to think like human to solve all these problems. With this, references are there for details. This is my Department of Computer Science. I hope you all know it or heard about it. And this is my beautiful Pakistan. Karachi, Islamabad, Lahore, Peshawar, these are all the Jaan of Pakistan, I must say. And in the end, thanks to all the professors, organizers, volunteers, participants for inviting me. Thank you so much. Sorry for apology for taking, I think, 5 minutes extra or what. Thank you so much.
Thank you so much, Dr. Muhammad Tariq. Any questions, audience, please?
Hello, Dr. Omara, Dr. Imran is here. I have one question. First of all, thank you for this wonderful talk, and the work you shared with us was wonderful.
Being an expert of AI, I would like to ask a question that when we design or model or develop a software that has to deal with AI techniques and biometrics and rest of the things, so then what are the challenges with respect to software engineering?
I would like to share the challenge which me myself is facing when I am working with my students and as a academic person in this area is the availability of the high computing GPU. For example, if a student is working on this technology, either he has to use the Colab, which provide the 16 GB GPU, but it will dies, the kernel dies after the 2 hours, while the training requires sometimes 2 days or 3 days. So your system is not content, you cannot use the online resources for training a customized system, right? And the second is obviously, I can afford the machine, but my normal students, my bachelor students, I am talking especially with respect to the public sector universities. They don't have the GPU resource. You have to make some extra effort. Either you have to buy it, or you have to, out of your comfort zone, you have to go to some other lab which is not in your vicinity. So you have to put these kinds of efforts. This is what I have faced since last 4 years. Secondly, with respect to knowledge, what I see that we have lost interest our students, and even I am teaching MS and PhD. I have PhD students with me. A major portion of our student community, including some teachers, left interest in the background mathematics. So if they take interest in linear algebra and matrices and computing, if they truly understand the meaning of computation, such kind of softwares, to build such softwares at local level isn't a challenge. So the challenge is to promote science and engineering in its true sense. In our DLD course, what I observed, that still our students are making the AND gates and OR gates. You see? So this is the dilemma situation. You have to update our courses. We have to update. Otherwise, we would left behind. Already we are, but so I think these are the top 3 challenges. You have to arrange hardware resources. You have to equip your academia with true science and engineering skills, and then you can build such systems.
Thank you so much, Dr. Humaira Tariq, as the Department of Computer Science, University of Yes.
I've got a question for Dr. Humaira Tariq, if it's possible to ask now. Hello.
Yes,
hello, Ji, I am listening.
All right, Dr. Tariq, thank you for a great talk. With reference to biometrics, have you looked at palm vein or the novel biometric methods, palm vein or wrist vein methods? And do you think that's
yes. Recently, as far as palm and vein is considering, I show the graph that there is less market for palm and vein authentication, and I personally work on a project on vein authentication with my students. We have made our own device in our lab and use it for vein authentication. And recently I am working on I am not shared that work due to the collaboration. It is not published yet. I am working on biological inspired model for vein authentication. So we use retinocortical mapping, and it's the log polar images. We model the whole retina, and it's basically we are trying to add up an HMAX layer hierarchical layer along with the deep networks. So the area, the latest area in my point of view is the biological modeling for any kind of computers. It is the merging of biology and computation these days.
All right, thank
I
you.
hope I answered the question.
Yeah, that's great. The only thing is, like, in the current circumstances where we're looking at let's just say poolable biometrics, and also where touching is to be discouraged, then
Yes.
veins become or palm veins and wrist veins become the most important.
Yes,
method.
that's why I am telling you that must look into HMAX model. The palm and vein, as I show the figures, it's not popular in the market, but the latest trend is towards the biological modeling for biometric as well. And the biological means the iris or retinal type.
Thank you.
Okay, thank you.
Thank you so much, Dr. Humaira Tariq, Professor, Department of Computer Science, University of Karachi. Thank you so much for your wonderful and insightful talk, and our audience takes a lot of interest. Now I would like to invite Professor Namrata Kaur, Riva University, Bangalore, India. Please share your presentation and start your class.
Good morning, everyone. I would request the permission to share my slides.
Yes, it is allowed. You can share.
Yes. Can you confirm, sir, whether the slides are visible to everyone?
Take it from full screen mode.
Yes.
And please also share your video.
Just a moment. I'll come back to Zoom so that I can share my video. I think I'll have to go ahead without sharing the video.
Yes, it's okay.
Is that okay, sir? Just a second. Good morning, everyone. Again, it's 12 o'clock here in India, but I think we'll be fine with morning itself. So once again, good morning, everyone, and thank you for joining me this morning for this talk on transfer learning. I'm really happy to be a part of this program. Really thankful to the organizing team, to the volunteers, to the participants, as well as to the fellow speakers here. So the topic of my talk is transfer learning. It's a specialized kind of deep learning. I'm really happy that the previous speaker spoke about deep learning, how it's impacting our lives, how it's making technology a lot better. Almost all fields of life are being touched by deep neural networks. So definitely a topic that cannot be left behind. A brief profile of a brief outline of this talk is going to be like this. We'll consider what transfer learning is, and then we'll see how it relates to deep learning, how it improves deep learning, what are some existing models that can be used in transfer learning. And then there is a case study which we have done here at Riva University in order to prove by research the results of deep learning. So what is transfer learning? It very much borrows from the concept of how we as humans learn. We know that we pick up a skill maybe in childhood, or we pick up a skill while trying to learn some task or some job, and then it's very easy for us humans to extrapolate that skill, to reuse that skill in order to pick up some other task. For example, I have learned to drive a bicycle in my childhood, and when I go ahead and start learning to drive a car, it's pretty easy for me. The control that I learned, the motor skills that I learned while driving a bicycle again, very easily transfer them to the job of learning how to drive a car. So this is the concept of transfer learning for us humans. So while we were working with deep learning networks, what the scientists thought about is that why not borrow this concept of transfer of skill or transfer of learning to machine learning as well, to deep neural networks as well. So essentially, the principle of transfer learning talks about that you take a pre-trained network, you take an existing deep neural network and reuse it for a different task. For example, I have trained a deep neural networks consisting of around 10 to 12 layers. This deep neural network has been successful in accurately classifying my images or detecting objects to an accuracy of around 97 to 98%. And then I have a task of classifying my local images, let's say images here at the university or images in my particular research problem that I'm working with. So what can I do? There are two options that I have. I can go ahead and construct a new neural network, a deep neural network from scratch, train this neural network on my small set of images. And that's also a viable option. But what has been observed in practice is that this neural network, which is trained on my local set of images, generally results in overfitting. And the accuracy results are, they do not generalize well to the test data set or the data set in real life. They just don't generalize well due to overfitting. So when transfer learning was tried here with deep neural networks, what they did was they trained the deep neural networks on huge data sets. With this kind of data set, which is huge and which is sufficiently diverse, the networks could learn the parameters optimally, and accuracy has been pretty good. There has been accuracy of the range of 97 to 98% with these huge networks which are trained on huge data sets and diverse data sets. So what we did here is that this is just showing how a deep neural network basically learns or trains itself. So it all starts with first layer of your neurons, which sees the image, which sees the input image. This is followed by the further layers, whose task is basically to extract the features. As you increase the number of layers in your deep neural network, the specificity of your features also is increased. In a way, we can say that the few initial layers of your deep neural network act as feature extractors, where you do not have to manually do feature engineering. The lower layers of your DNN will automate it for you. And what this brings us to is that these few layers of your neural network, these few initial layers of your deep neural network, can be used as off-the-shelf components for other tasks where you do not have the luxury of huge enough data sets so that you can train your entire deep neural network from scratch. So essentially what is being done is that we are taking the deep neural networks which have been already trained on huge data sets, and parts of these deep neural networks we are using as plug and play features to our new neural networks, which we actually want to use for a different task, for a task which is maybe relevant to my research problem or to my local problem. This is what basically happens. I have here around 5 layers of neural networks in all. The 3 layers here come from a pre-trained model, from an existing model. I think Dr. Humaira spoke about certain pre-trained models like GoogleNet, AlexNet. So these 3 layers we have borrowed or we have used as it is from one of those neural networks, deep neural networks. And then I have 3 specific tasks. Let's say the classification task for my students at the university, or the task of identifying objects like unidentified objects and at an airport or something. So there is not a big enough data set for these problems, but we do have big enough data sets for generalized problems on which these 3 feature extraction layers have already been trained. So what we have done as a part of transfer learning here is that we have reused the 3 initial layers which have generalized features already represented in them. And we have substituted 2 layers or maybe just 1 layer or maybe just a classification layer on the top of these layers. And then this branch of your neural network is specifically doing the task that you are interested in. And similarly, this branch of your neural network is specifically doing the task that you are interested in. It's solving your particular research problem, and at the same time, it's leveraging the work done by other researchers who have already trained these 3 layers of overall network for you. This diagram I have borrowed from the internet. The source is presented here. So this is a convolutional neural network with around 6 layers, and 5 of these layers I am retaining in my particular research problem, and these top 2 layers have been chopped off. I do not need them because they are too specific to the problem that was used by the original developers. So instead of these 2 layers, I have supplied my own classifier here. I have written my own shallow layer of classifier, for example, SVM or some other, or just a softmax layer which does your particular task. Let's take an example here. Suppose I'm using AlexNet or I'm using ImageNet, which classifies images into 10 categories, and the model is trained to identify 10 categories. But my particular problem is, for example, to identify tumors in lung images, in MRI images of the lung. I have just 2 possibilities. I have to classify my images either as cancerous or non-cancerous. So just 2 classes are there for me. What I can do is that I can retain the images in bottom 4 layers, which have generalized representations of the features, and I can have a 1 classifier built on top of it, which can do the classification into cancerous and non-cancerous. And my classifier has the luxury of using all the features that are there already, in the pre-trained 4 layers of my model, which I am borrowing from. Now, once you have decided to go ahead with transfer learning, perhaps because you do not have enough data for your classification problem or for your particular object detection problem, you can do 3 things. You can fine tune your model, which means once you have written the last layer for your neural network, you can decide on whether you want to fine tune, whether you want to use it as it is, what is going to be your part of the work in your research problem when you are using transfer learning. See, what I am saying is that transfer learning helps you reuse part of a neural network. It helps you to reuse the weights that have been learned by a neural network. It does not mean that our job is totally, smashed out. We still have to do our job. You still have to train your particular classifier. Now, this training of your particular classifier under transfer learning in deep learning involves something which is called as fine tuning. What it means, generally, or in very plain terms, what it means is that you have taken up parts of an existing deep neural network. You have written your own classification algorithm on top of this neural network. Now you have your own data, which is smaller insights, a smaller data set. So what do? You use that data set to train the model, which is constructed once more. This training is in such a way that it does not change the already learned weights of your pre-trained model. Still, it makes a little change to the weights. It makes a little tweaking to the weights so that your model is now aware of your data set also. The model that you are using for pre-training is aware of the data that it has been trained on. But now you're working with a different problem, and it's up to you. It's important for you to show your data also to the neural network. That is what is done in the fine-tuning step. So you have constructed your model, which consists of feature extraction layers from a pre-trained model like AlexNet or GoogleNet. And on top of it, you have written your own classification layer, or maybe a couple of classification layers and a softmax layer. After then, you have to train your this new deep neural network on your small data set also. What happens as a result of this is that the weights of your layers, your 2 layers get changed, and there may be a little change in the weights of pre-trained part of your network also. Now this change is up to you, whether you want to change the existing weights or not, which is decided by whether you want to freeze your model, freeze the weights of the model or not. Based on what do you want to go ahead with, what do you want to do with your new model, you have 3 strategies available for fine-tuning your data, fine-tuning your model. In one strategy, what we do is that we just change the topmost layer of our deep neural network, which is the softmax layer, the final output layer. We just truncate it and replace it with our own softmax layer. This is suitable for a number of problems which are very similar to the problem on which your original DNN has been trained. My second option generally is to do a fine tuning of entire neural network that you have constructed using transfer learning, but use a smaller learning rate with your data. Using a lesser learning rate, a generally accepted value for this smaller learning rate is 10 times less. So when you are training your deep neural network on with a smaller learning rate, the weights that have been learned with previous training of the pre-trained networks do not change much. So you get the benefit of using earlier weights, and at the same time you get to show your data to the neural network and hence customize it according to your requirement. Then a third way of generally applying fine tuning on a transferred deep neural network is that you freeze the weights for initial layers. Freezing the weights means when you show your new data to the deep neural network, this data does not change the weights of the pre-trained layers. So whatever change your data brings to the DNN only takes effect in the later layers or the layers that you have constructed for your model. Based on what kind of data you have available and based on how similar this data is to the data on which your pre-trained model has been trained, there are 4 cases of transfer learning. The first case is that your data set is small and it is very similar to the original data set. For example, if I work with ImageNet, this ImageNet is trained on 10 classes of general images. And my problem is also similar. I want to classify general images, but I have a very small set of images. So what do? I do not fine tune the entire model. I just add one SVM on top of it or just one classifier on top of it and train that classifier with my data set, and it works fine. Case 2 is when, of course, the data set that you have is small and it is very different from the original data set that the pre-trained model has been trained on. In this case, what do we do is that we add a couple of classification layers or maybe just one classification layer, and you reuse the weights that have been trained earlier. The activation part which has been obtained earlier is just used as it is for this particular case. Case 3 is that when you have sufficiently big data set, and it's similar to original data set also. It's similar to the data set that was used for training your pre-trained network. In that case, you can by always go ahead and fine tune your entire network. This brings us to the final case where you have a large data set and it's very different from the original data set of your pre-trained network. So in this case, it's pretty much not beneficial to use transfer learning because you have large enough data set and your problem is quite different. So go ahead, write your DNN from scratch, or you can go ahead and fine tune the entire model yourself. If I may repeat here, fine tuning means passing your own data through the network through the process of backpropagation. So these are a few popular pre-trained models available to us for tasks of image classification as well as object detection. ResNet is very popular these days, both ResNet 18 and ResNet 50. Then VGG also is quite popular for the tasks of object detection. We have AlexNet, and of course there's GoogleNet from Google. So what is the general purpose of doing transfer learning? One very important factor for which transfer learning is used is that you do not have sufficient data and you want to take the advantage of pre-trained networks. You want to just, reuse what already exists because your problem is similar to what a problem has already been solved. This is one purpose of using TL. Another purpose of using TL is that there's a well-known architecture which has proven successful for a particular problem, and you want to use a similar architecture instead of going and inventing an architecture of your own. You just want to use the existing proven architecture. The third use of transfer learning is for feature extraction. So this is a problem where you do not have any labeled data available. So even manual engineering of features is not looking feasible, or it has not shown you good results. So what do? We just use the existing features which have been extracted by deep learned models earlier, and use these as a feature extractor for your particular problem. This is a case study conducted by us at Reva University. So what we wanted to do is we wanted to identify our students in the campus. So for example, somebody is missing classes, and we want to see where is the student at that particular moment of time, or we wanted to identify a vehicle which is wrongly parked in the campus or something like that. We had very limited set of images. There were around 1,000 images, and if we tried writing our deep neural network from scratch on this set of images, which resulted in overfitting. You know, the model could work briefly, or it could work on the images from the campus, but it didn't work when we got images from outside the campus or something like that. So we suffered with the problem of overfitting. Then we decided to go ahead and use transfer learning in this case. So what we did is that we trained our model. We constructed a pre-trained model on CIFAR-10 dataset. CIFAR-10 dataset is a publicly available dataset of around 60,000 images. Each image in it is a 32x32 image. It's a color image. And we have divided this 60,000 images into training and test set, where there are 50,000 training images and 10,000 test images. Training images have been taken randomly from all 10 classes of the original data set. From each class, they picked 5,000 images. The test images were also picked randomly for each of the 10 classes available in the original CIFAR-10 data set. And there were 1,000 images from each of the classes. Aeroplanes, automobiles, and all that. So it's a totally generalized data set which can help you with problems related to general classifications of vehicles, animals, or automobiles around us. So what did we do? We started with a convolutional neural network of around 7 layers, which was developed in Keras. Sorry, it was 5-layer network, which was developed in Keras. And we wanted to use this model to classify students' images and vehicles inside the campus. So we trained this neural network on CIFAR-10. When we tested it for validation accuracy, we got a validation accuracy of around 87% in 100 epochs. Then we decided to go ahead and try with transfer learning, what will be the accuracy with transfer learning. So for doing that, we took this pre-trained model. We froze its 4 feature layers, which means when we further showed our data, we did not change the weights of these 4 feature layers. On top of these 4 feature layers, we coded SVM as the last classifier. And then when we showed our smaller data set, when we showed it the local images, the accuracy that we got was around 95 to 96%. And the training time was reduced by 39%. Earlier, when I trained on entire CIFAR-10, it took around 180 to 190 seconds to train. But with a fixed model, with fixed 4 layers, which I did not have to train, it took just around 130 seconds or maybe 125 seconds. And the accuracy also increased by around 10 to 11%. So what we have to, this graph shows us the relative gain in validation accuracy when we tried to train our model in 100 epochs on full CIFAR data set. And this is when we did a reuse of 4 feature selection layers of our original model trained on CIFAR-10 data set. So there was a gain in accuracy by around, I think 8 to 10%. This is what we gained in terms of training time. It was around 60 seconds, around 1 minute of training time was saved. And this training was conducted on a Microsoft Windows machine with NVIDIA GTX 3000 GPU. I'll summarize what I had to share. It is that transfer learning is a feature in deep learning. It's a facility or a technique in deep learning which allows you to use existing models, which are also called pre-trained models. With these pre-trained models, what do you do actually? You reuse the weights of some layers, which are called feature layers or which are called initial layers. You initialize your own neural network with these weights without calculating the weights, without tweaking the weights. You just reuse these weights. You initialized your neural networks with these weights. And then in order to take care of your particular classification or object detection problem, you write just one algorithm or just one layer on top of this deep architecture. And this has shown to be, this has proved to be really good in tasks like image classification, object detection. We already have spoken about these two. Transfer learning is also proving very beneficial in the tasks like natural language processing. We have heard about BERT model from Google. We have also learned about how Google Translate is using transfer learning very effectively. This also has been now used in medical diagnosis, where you can use the models turned on a models trained on a different disease for a diagnosis of a different disease. For example, the models trained on particular types of cancer, let's say lung cancers, can also be used to detect certain blood cancers and certain cancers of brain. So this is where I would like to stop, and I'm so happy to be a part of this program. Thank you for your patience, and I'll be happy to answer any questions if there are.
Well, if I'm allowed, I would like to ask my esteemed colleague, Dr. Cole, how many? Sorry.
Yes, you can ask.
Thank you. Well, it was really very interesting presentation, especially this topic on transfer learning is rather, let's say, new. I would like to ask you what is the actually quantity of data that you typically need for your tasks in deep learning, with or without transfer learning? How many data pairs? Few thousand, millions? What is the approximate quantity?
That's a very good question. In fact, all of us here, who we have all heard about deep learning, and we are very interesting. We feel like it's going to be magical and our problem is going to be solved. But yes, it hugely depends on how much data you have and how relevant is your data. Suppose I work in computational biology. I work with cancer studies. So if I decide to go ahead with deep learning, I'm hugely limited by the amount of data I have available. They typically say that in order to have good classification accuracy with a deep learning model with 5 or more layers, you need to have data in terms of at least 2 to 5 GBs. The data which can be, the deep learning network should be able to get the values of all its parameters. I have a DNN of around 5 to 7 layers. It will have parameters which are in thousands. Sometimes a deeper neural network will have millions of parameters. So if your data points are less than the number of parameters your DNN has, it's going to be a total failure.
Of course.
No, it's not going to give any advantage. And we know the parameters means they come from how many factors, how many dimensions you have in your data. It's that kind of a relationship. More is the dimensionality of your data, more is the number of parameters that your DNN is going to have, and you should have your data in proportion to that. So I cannot put a number on it that you should have 1 GB or this, but it relates to how many parameters you have in your DNN. And your data should be at least 5 times the number of parameters in order for your DNN to work really well.
Okay, so anyhow, we are talking about 1,000 or million of data input out data pairs. Okay, thank you very much.
Yes, thank you, ma'am.
Thank you so much, Professor Rewa University, Bangalore, India.
Thank you so much, sir. Thanks everyone. Thank you.
Now I request Professor Dr. Chitjana E. Sedlija, Metropolitan University, Serbia. Please start and presentation.
Thank you. May I share my screen?
Yes.
Okay. Okay. Sorry, let me just zoom, share screen. Okay. Share. Can you see my screen?
Yeah.
My presentation?
Yes, we are.
Okay, thank you. Let me just move this. Okay. Well, I'll talk about the role of evolutionary computing or soft computing as a major part of artificial intelligence in engineering, in solving engineering problems. The reason why I asked my esteemed previous colleague about the number of input-output data pairs is that in engineering frequently we have small data issue. So, okay, let me, okay. I don't know what's happening, sorry. Okay, so this is a brief outline of my presentation. Actually, I'll be mainly talking about the application of soft computing or evolutionary computing in particular in optimizing industrial or manufacturing processes. We call that parametric process design. I'll present some findings from the extensive literature review, and then I'll show the methodology that I have developed to deal with this issue. Then I'll show you results of 3 case studies and conclusions based on these applications. So in engineering, let's say this is the typical model of engineering process. So there is a process, we produce something, process something based on inputs, and we delivered typically today several or multiple outputs, which we call responses. And the whole process is controlled by some control factors that are used to manage the process. And unfortunately, they are affected by noise factors, which we cannot control. We don't like them, but we have to accept them and somehow deal with them. In a smart, so if we are talking about reference to Industry 4.0, smart factory is very essence of Industry 4. And it is supported by IoT, big data, and analytics, artificial intelligence, etc. Contemporary products and processes are becoming more and more complex, and anyhow nowadays almost all of our in engineering processes deliver multiple outputs which are correlated. Those are not independent outputs but somehow interrelated. So new emerging industrial processes are very complex, with very complex input-output interdependencies that are typically highly nonlinear, multimodal, and there are a large number of variables involved. Traditional optimization methods are not fully able to tackle this complexity, so we are relying nowadays on the advanced optimization methods that are mainly based on evolutionary computing. Here we talk about various statistical and machine learning techniques that are needed for data processing or data pre-processing. And then we're talking about artificial neural nets that we use for process modeling to develop this process model, because we don't have typically for new emerging processes, there are no analytic relationships of a process. Actually, they are unknown. And at the end, we use evolutionary algorithms to perform the process optimization. Now, let me show you what is process optimization in our case. So this is a process. Okay, I have already explained that. So the major task or the objective of process optimization is to achieve the desired value for every or each response. So we want to achieve desired mean value, but also minimize variability. Because let's assume we have a process that delivers several thousand of products every day. So we want that the mean value of product characteristic is as close as possible to the target and to reduce the overall variability. And obviously these, there are typical several constraints, limits, etc. few years ago, I have published a book on advanced multi-response process optimization by Springer. And here, this could be interesting to note. So there are these conventional optimization methods that are typically based on statistical techniques, and non-conventional methods that are based on artificial intelligence. And today we'll talk mainly about these meta-heuristic based optimizations. Last year, I have published a paper in Apply Soft Computing, where I basically perform a huge literature review on the role of meta-heuristic algorithms in optimizing manufacturing processes. And okay, I found that a genetic algorithm is the most frequently used one. However, it is not the most efficient one. So these are findings from several hundred of papers, even more. So the point is that it has been found that the algorithm called particle swarm optimization, which is swarm intelligence, particle swarm optimization showed the best results. So clearly outperformed genetic algorithms, simulated annealing, and many, many other algorithms, except two algorithms, TLBO, so-called teaching learning based optimization, and Kuka search algorithm. So there are only these two algorithms that in a literature review, I found it slightly better than particle swarm or optimization. I just need to highlight several issues that I found in this literature review. First of all, for some comparisons, the sample was rather small. And second, well, the meta-heuristics are relatively tricky for application mainly because of repeatability, because the repeatability of the meta-heuristic algorithm results cannot be guaranteed. What I want to say is that you run the same algorithm with the same setting 10 times on the same problem, and you will get similar, very close results, but probably not identical results. For example, this issue has not been very extensively discussed in scientific papers. And also, what are the concerns that should be also addressed is that it's so-called algorithm robustness. These meta-heuristic algorithms are mainly very dependent on their own parameter tuning, call them hyperparameters tuning. And also this issue has not been considered so much in literature review. Then I mentioned at the very beginning that it is the objective of optimization task is to reach the target mean value, but also to reduce variation. Not all studies have been dealing with reducing variation. And major issue with respect to meta-heuristics is the formation of objective function, because, well, we have multiple outputs. As I said, we call them responses in engineering. If you want to form one objective from those multiple objectives, then typically people use some weightings approach. They allocate some weights to several objectives in order to sum up them into one objective. And those weights are typically subjectively assigned. And that is a really big issue. There is another way how to resolve that, using so-called Pareto front-based optimization algorithms. Here I show small example. And they are fine if you have only two objectives, or maximum 3. Then you have one graph and then you can locate the points that you like. However, if you have several responses, more than 2, then there are multiple Pareto fronts. And then basically are doing trade-off between 2 or 3 or even more Pareto fronts. And those trade-offs are again resolved based on subjective consideration. So these are really 2 very important issues, because if objective function is not formed on a totally objective manner, then the results of your algorithm won't be good. Okay, here I just listed, this is a brief description of the most frequently used meta-heuristic algorithms, such as genetic algorithm. Here in this red cloud, you can see several parameters that are needed. Those are hyperparameters of genetic algorithm that needs to be set in a specific way. So you have to choose the value for each one of them. Simulated annealing, again, the same story. There are several parameters, initial temperature, temperature function, etc. We don't have a time to go into all these settings. So again, there are several parameters that needs to be finely tuned in order to guarantee that your algorithm will actually find a global optimum. Particle swarm optimization, which has been shown as a very effective one. Again, several parameters to be set. And also, I included in this discussion a relatively newly developed algorithm called teaching learning based optimization. Why? Because that extensive literature review showed me that PS particle swarm optimization was the best algorithm except TLBO. So TLBO showed in literature review on several studies show slightly better results than TLBO. What is important about this TLBO is that there are no specific hyperparameters to be set. So in order to run this algorithm, you just need to define population size and number of iterations, which is common for all algorithms. So there are no specific hyperparameters. Okay, now I'll just briefly present methodology that I have developed. I called it Intelligent System for Multi-Response Robust Process Design, shorter ISMR-RPD. It is based on the theory of Japanese scientist Taguchi. The point is just briefly to understand signal-to-noise ratio, SNR, and quality loss. Signal-to-noise ratio is a measure that takes into account both the response mean value and variability. So it is one value that takes into account both average and variability. That is important. Based on signal-to-noise ratio, we have quality loss function that shows you basically a loss that user will have if the product response deviates from the target. Why that is important? Because it shows you the significance of one response for the user. Okay, so what I did first, this first part of my method is basically statistical approach that deals with data pre-processing. So once when I express my responses, mainly obtained from experiments using this quality loss that I have already mentioned, then my responses from our process are correlated. They are not independent. And we have to make them independent. So that's why we have to apply, actually I applied principal component analysis to obtain a set of independent data. Then I applied gray relational analysis to synthesize these independent data into one single measure. How? Here we also need weights. And these weights are actually obtained from principal component analysis. The bottom line is that at the end, I get a single process performance measure that is obtained on a totally objective way from one side, and from the other side, it encloses 100% of variability of original data. Okay, so from multiple objectives, I get one objective, and I obtained it on a fully objective manner. Now, I can calculate the effect of process control factors on that process performance measure. So this is pre-processing. Then I need process model. How will I develop it? Using artificial neural networks. So at the end, I have this process performance measure that I have just calculated using this data pre-processing method. At the beginning, actually at the input, I have process control parameters. And such a neural model is input for meta-heuristic algorithm that at the end should find the optimal process parameter settings that will satisfy the requirements for my responses from multiple responses. I mentioned those 4 meta-heuristics that I tried out here, and I compare them with respect to 3 criteria. First is quality or accuracy of the obtained solution. So obviously we would like the objective function to be as high as possible. Convergence speed, number of iterations that algorithm needs to locate the global optimum, and very important, algorithm robustness. So actually it is dispersion of results obtained by different algorithm settings. I told you that for the first 3 algorithms, there are several hyperparameters that need to be tuned. So if we tune them in one way, we will get one results. If the setting is slightly different, probably we'll get some other results, etc., etc. So then we don't know actually how to tune them. So we perform less dispersed results, which would mean that the algorithm is much better. It's robust. Here is the objective. Here is in a MATLAB the pseudocode of the objective function, and yeah, here I showed several settings for genetic algorithm. Here also, so in total I run 9 genetic algorithms with different settings. For simulated annealing, even more, 36 algorithms. For particle swarm optimization, even more, 60 algorithms. And for TLBO, teaching learning based optimization, since there are no hyperparameters, basically I could have run only the algorithm only once because there are no settings. What I decided to do here is to repeat the algorithm 5 times to assess the repeatability of the TLBO algorithm. Okay, this is the first case study. Here, it is very important to note that I've asked a previous colleague about the number of data that she needs to run deep learning, and it's kind of one minimum few thousand, it goes up to a few million. In engineering, typically we do not have such a large quantity of data. So engineering optimization is mainly done using experimental data. And we run experiments, collect very few data, and perform optimization on them. Historical data process from process control charts. But again, for example, this is, in my case, big data study, where I have for example, these are data that I took from control chart, historical data, but here I have only several hundred of data, not thousand. Okay, so basically using these data, historical data, these are process control factors, these are responses, I applied these, I call them factor effects approach, which is data pre-processing, to at the end generate these gamma value, which is process performance measure. So based on that, I developed process model using artificial neural nets with only 3 layers. You can see these neural nets are quite good. Error is in order of 10 on around 0.91, which is not perfect, but not bad. And then I applied genetic algorithms, simulated annealing, particles form optimization, and TLBO to see the results. Here, for example, first row, you can see the range of process performance measure using different settings of the algorithms. And at the end, we can see that TLBO found the highest objective function, and in all repetition, it found the very same result. Particles form optimization also managed to find such a high objective function, but there are some dispersions. Simulated annealing, here there are a lot of dispersion, and simulated annealing, a genetic algorithm did not manage to find such. In this case, TLBO showed excellent accuracy, repeatability, followed by PSO, and genetic algorithm and simulated annealing showed inferior results. And TLBO is not so fast as the other 2 algorithms, but anyhow, it is very robust and managed to find to locate the actual global optimum. Here we can see the comparison on, I'm sorry, case study 1, big data. Okay, this is still case study 1 on the big data. We can see the comparison with other methods from the scientific literature review. We can see that this method found much higher process performance measure than the other methods. So the method intelligent system for multi-response robust process design itself is significantly better than the other methods, but it is very important which optimization tool you use. So the point is here, TLBO shows in general the most preferable results. It is slightly slower in terms of converging to the global optimum, but at the end it locates the global optimum. Okay, the next study is a study on a small data. Here, whole optimization was performed using experimental data and using only 15 experimental trials, which means that I have only 15 input-output data pairs, which is really extremely small. Okay, here I have 7 responses, 7 outputs, and 2 process control factors. Here we can see details. Okay, we don't have a time for that. So this is the pre-processing method. At the end, we obtained this process performance measure, unique one, out of 7. So we combined these 7 responses. After this pre-processing, we obtained the process performance measure. This is modeling. So please note that here, artificial neural net showed really excellent performance where error is in order of 10 on -6 and correlation is 0.99, which is really excellent. Then I applied again these 4 algorithms to actually find the optimum. Again, TLBO resulted with the best result. It showed the excellent accuracy, repeatability, and robustness. And it was, in terms of speed, it was, let's say, similar to the other 3 algorithms. Again, comparison with other studies showing that the proposed method always found better results than the other commonly used studies. And the third case study, again, this is small data study. Here, we perform experiment had at the end 18 input-output data pairs for the whole optimization. We repeated the same procedure, as you can see. The neural net that we obtained, error is in order of 10 on minus 6. Correlation is perfect, is 1. Again, we used these three, four meta-heuristic algorithms. And again, TLBO was the best one. You can see that PSO and TLBO managed to find the highest objective function and the other two not. Again, comparison with other methods showing that this method is significantly better than the others. Okay, now let's do some discussion on all these. First, let's see this small data versus big data. And in my case, big data is few hundred, not few thousand. So in terms of optimization, there is no optimization itself. There is no big difference between small and big data. However, in terms of modeling, there is a huge difference. So from theory, it is believed that, and not only believe, it is true, that artificial neural nets need a large quantity of data, especially if you have large number of design variables. In my case, those are process control factors. So let's see the results in a case study 1 with the big data. Here, error was in order of 10 on minus 4 and correlation around 0.9, which is fine. We obtained the process performance measure of 0.87, which is good. Let me just mention that this process performance measure, it can go between 0 and 1. So 0.87 is quite good. But in case studies 2 and 3, networks were, error was in order of 10 on minus 6 and correlation was almost perfect. So in my case, it is really funny that the big data artificial neural network, actually the network trained with big data, showed inferior results to the networks trained with small data, which is totally contradictory to theory. So why? What is the reason? In case study 1 that used big data, we collected data, raw data in industrial conditions. So data that you are taking from industrial conditions are typically very, very noisy because they are collected from different people in different time, etc., etc. In case studies 2 and 3, the whole optimization was run using experimental data. So we performed designed experiment in controlled environment. The point is that at the end we got, let's say, higher quality data. So that's why in in my case, the INNs developed in studies with the small data showed better results than with the big data. Anyhow, this has to be analyzed further on a large number of studies with big data. Let me just tell you that in engineering, it is not easy to obtain historical data about process because people are not very eager to share with you their process data, because sometimes, you know, it is a matter of it is their very, let's say, procedure that they don't like to share with others because it might be secret, etc., etc. So that's why sometimes we are forced to deal with small data, actually, to do these experiments. and yeah, let's just comment, because frequently when I publish paper on this topic using such a small amount of data, people ask me, but how come you manage to get such an excellent network with such a small amount of data? It is because of this pre-processing method. That includes normalization, standardization, and very important, fully objective integration of several objectives into one. Okay, so regarding meta-heuristic performance, okay, here I draw some guidelines on the settings, hyperparameter settings for genetic algorithms, simulated annealing, and particle swarm optimization. For TLBO, fortunately, there are no hyperparameters. And TLBO really showed excellent repeatability in these studies. I worked with the population size 5n, where n is number of design variables, and it showed excellent results. So even the population size is not very high. In terms of comparison, definitely TLBO showed significantly better results. Okay, let's say TLBO showed better accuracy and robustness than PSO. However, it is slightly slower than PSO, but I think that shouldn't be a big issue. And it showed much better results than the other two tested methods. In the future, I will also test the other algorithms, such as that Kuko search algorithm that might be comparable to TLBO, and also some of the newest procedure. Okay, to conclude, so we are talking about the soft computing in smart factories being a major part of Industry 4. Regarding machine learning or artificial neural nets, we definitely need them to model the smart factory processes. And what I wanted to prove is that here the data quality is equally important as the data quantity model the process. Regarding meta-heuristics, comprehensive literature review showed that PSO is significantly better than all the other algorithms except TLBO and Kuko search. In this case study, TLBO really showed us excellent results, so I would highly recommend it for usage. And okay, my future, actually I'm already working on testing on this Kuko search, so we'll see. TLBO does not need any specific tunings, and that is very important issue. It is slightly slower than PSO, but that shouldn't be a major issue. In terms of future work, for big data studies, which is not easy to get, because people, as I said, people do not like to share their big data about their factory. The other sorts of neural nets will be used, deep learning, extreme learning, but it depends on the number of data that I get. So if I have only a few hundred, hardly that I can use extreme learning data. Yes, and to highlight at the end issues or recommendation for people dealing with this optimization. Always treat both the response or output average, mean value, and variability. If you want to form single objective function from multiple objectives, then it has to be done on a totally objective manner, not using some subjectively assigned weights, saying, okay, this response might be important, more important than the other one, etc., etc. And there are some, let's say, ways how to do that totally objectively. And yeah, to highlight the issue that Pareto front-based approaches are good, but only if you have 2 responses or maximum 3. For more than that, I wouldn't recommend using Pareto front-based approaches. If you would allow me, I would like to share with you information. Some of you might be interested in these. I'll be editing a book on a topic, actually, title is Soft Computing in Smart Manufacturing Solutions Towards Industry 5. It will be published by a highly ranked publisher, De Gruyter. Here you can see the, so it will be edited by me and my esteemed colleague, Professor Paolo Davin. And here you can see, let's say, the topics. So I know that majority of you are mainly in software engineering, but if you have some interesting research with application in manufacturing, I would kindly invite you to contact me and think about submitting a chapter. Okay, so this is the let's say end of presentation. I have just forgotten that I forgotten to thank to Professor Imran Bajwa, who invited me to join you today. I'm really happy to share, let's say, my insights with you, and I really enjoyed the previous few presentation. Okay, so I would end my talk with this. Do we have some questions or comments?
Thank you so much, Dr. Jana. Any questions, audience? Any questions from audience? Dr. Taimur, would you like to ask some questions?
No, thank you.
Dr. Humaira Tariq, would you like to ask some question? Thank you so much, Dr. Tijjana.
Thank you.
University, Serbia. Thank you so much on the behalf of Islamia University Bahawalpur and Department of Computer Science and Department of Software Engineering. Now I request Dr. Taimur Khan, University of Greenwich, London, UK. Please start your talk and share your presentation.
Right. Thank you. So let me share my screen. So,
yes, it is visible. It is
visible.
Yes, it is visible, and we are hearing you. Please start.
All right. Okay. Thank you. So first of all, thank you for the invitation and giving me an opportunity. I will stick to the schedule. Just to briefly introduce myself, I have a background in software engineering. Luckily, I am also the graduate of the same university, Islamia University of Bahawalpur. Later on, I had my MSc at Leicester in UK, and I had my doctorate in formal verification from Austria. I've got some teaching experience, teaching at different institutes. Some of the institutes are premiers, starting from MIT at US, teaching in different universities in UK and Austria. I've also extensive research experience. I've got an opportunity to work at NASA, MIT, at Intra, and different institutes. I have published my research mostly in A-star and A-rank conferences and journals. I've got a chance to win several best paper awards, and my research has been funded actually by Horizon, European Commission, Austrian Science Fund, and US DARPA. Most recently, I won actually a project in SureSec, which actually worth 10 million euros. That is actually on the security of e-commerce system. I've got also some software industrial experience. So quite a diverse experience. And based on that, I will share my current thoughts, what could be really a good direction for students to move on. So I will start with what is a computer program. I'm sure every one of us knows, and all of us have been writing probably software programs, which are hundreds, thousands of lines of codes. But let's talk about, can we really make them certify? Can we really talk about their reliability, their security, and their more rigorous behavior? So a computer program, of course, is a collection of instruction which performs certain tasks. We can ask anything to do, and computer usually does this job nowadays for us. But it does the job while executing, and for execution it really requires runtime libraries, for example underlying JVM or some C libraries on top of the operating system. So with this simple description of a program, can we somehow show that this computer programs performs a task which we have asked it to do? And now the question is very weird, and the answer which we get it that yes, probably we can do it, but the current techniques through which we can say that the program does the job which we desired is testing and simulation. Unfortunately, they both are either random or highly random. So they are not rigorous, they are not exhaustive, and unfortunately, there is no definition of a good test or a good simulation. You can test it, but you cannot ask somebody, can you tell me what is a good test, what is a good simulation? And unfortunately, it shows the presence of bugs, but it does not show the absence of bugs. And that's more critical. Usually, these approaches are more empirical and statistical. We tell you the possibility, probability, okay, I'm 50% sure about the reliability of the system, or I'm 70%, I'm 80%, but does not give you any guarantee, any assurance where you can really believe in that yes, it works. I mean, I've been listening to the previous speakers, and they were also talking about their systems in terms of some empirical evaluation, telling us, oh yeah, this is the confidence. That's good, but can we really go further and look for more rigorous evidence that our program really works fine? And one of the techniques through which we can establish this kind of guarantee is mathematical logic-based reasoning, which makes sure that yes, your software design or program does the job as intended. Let's look at a very simple example. This is just one line code. Every one of you have done it probably several times, and know everyone can probably write. Nowadays, high school boy can write the same code. If I ask a program to add 2 integers, I will find this simple solution of one liner where I will write, yes, please return x plus y, and that's it. Now I will start asking some weird questions. Of course, you are not bound to answer it, but does this solution solve the problem of adding 2 integers? The answer is certainly no. Why? Because it does not add any 2 integers. In fact, it adds only the integers in a very specific range of the Java integers. Now, do we know really the solution completely? That this addition, the simple addition one, which is return x plus y, do we really understand it? What does it do? And the answer, unfortunately, again is no. Because when I ask the system to add 50 and 50, it returns 100. But if I give him some other value, it returns -2, which cannot be the case, because we know from the fact that adding 2 positive numbers does not give the answer as a negative number. So these 2 big numbers cannot be added up to -2. And now we do not know what really this plus is doing, this x plus y. What does this really plus is doing? We don't understand the meaning of this plus. And now we ask ourselves, is this really solution then correct? And the answer, unfortunately, is again no. based on the fact that we have seen that these two additions do not really sum up the real two numbers, but add to computers which are Java, different behavior. So you see that even a very small program couldn't answer for these simple questions. And unfortunately, these solutions, the current solutions like simulation and testing, they cannot answer these kind of questions. So for this, we really need to look for some, sorry, some solutions which are beyond the simulation and testing. And let's refine this example with some additional knowledge, which is specification, for example. Sorry. So what we understand from the knowledge of computer is that actually this X should be in a certain range and Y should be in a certain range. Then this function produces the result, which is also in a given range. So with this additional knowledge, we can ask again the same question, that if I add this information, now does this program perform the task which I asked it to add any two integers? Now the answer is of course no, because still it can add up to two numbers with an incorrect result. But now I know the problem and I can go further to fix these errors and make the program really correct. So what are those two corrections which I can make? Of course, there are several ways which one can do that, but we have just here highlight the two possible answers. So the first solution is that instead of returning the integer, I change the return type into a long so that the values do not overflow and I get the result into the right range. If that is not possible, the second solution could be that I restrict the values of X and Y within the function, and I say that X and Y strictly have to be the half of the values of the range of X and Y, which are supported in Java. So of course, in these two ways, we are not going to only save the memory, but we are also going to save the time. We are going to understand the program more rigorously. And now we understand what actually it is doing, because this is definitely adding the two numbers which are in these two ranges. And the answer will strictly be within this given range of the Java. So within, if I will provide the X and Y values within these range, I will never get an unintended result or an surprising result. I will always have a correct result. And this is exactly what we want. Unfortunately, simulation and testing cannot fix these errors. So we need this additional knowledge. Of course, there are several other ways in which people inspect and look into the programs and designs. One of them is manual inspection. That is a typical industrial practice where some critical software is written. They are good because they are based on the human discussion, but unfortunately, there is no rule for the guidance of the discussion, how we should really talk about it. You can have your own view about the code. I can have my suggestion, and we may not come to the conclusion. Testing and simulation, I've already explained in the start that they unfortunately show that the program or the design works in only specific cases. They do not tell us that whether my design or program will work in all possible cases, whatever I provide. And that's what we really need. I mean, as previous speakers have been talking about different systems, particularly embedded systems and Industry 4, where the systems are automatically working. We also know that with the current development of the automotive vehicles, everything will be working automatically. So we really want them to make sure that they never collide, they never have an accident, they never scare us, and they always take care of our safety and security. So we work based on the formal methods, formal verification. And this particular approach works in the simple way. It asks you to give you a design or a program, and it asks you also to write your intentions, some requirements, your description of what it should do. And then the tool automatically combines these intentions and the actual program are designed and generates some verification conditions, which are actually some mathematical theorems. And then it has to be proven automatically or semi-automatically. If we can prove it, we actually have shown that this program exactly does the job as it is written in the specification. And if we cannot, then it means there is some definitely some gap, some error. There are a bunch of tools. Of course, I will not go into the details, but I just want to introduce you this new area through which you can really certify your design. And this technique is, of course, not new. It started back in 1967 and then moved on after every couple of years, some new development. The most recent development in terms of theory has been in 2001. Practical developments are, of course, going on. I will introduce them later. But at the moment, let me show you a very small demo of an actual program. Do you see my screen? And do you see a simple program written in Java?
We can see.
Okay, you can see. All right. So now this is a very simple program, which is just adding two numbers. But unfortunately or mistakenly, I have, instead of writing plus, I have written minus. So if I want to catch this error, usually it's difficult because I'm doing whatever I want to do. But now if I start asking the system to check it, it is going to immediately tell me, yes, there is something wrong. And the benefit of this program here is, which is not a typical program which you have seen in Java. If you see, here are two different coding colors. The blue one and the black one is a typical Java program, but the green one is the Java comment. But in the comment here, you see, I have provided some additional information, which is my specification or my description, my intention. I ask him that this A is to be greater than 0. And I also want B to be greater than 0. And I want result to be the addition of two numbers. That's what I intend to do. This is my intention. This is my requirement. This is my description. And this is now the actual code or actual design which it is doing the job. So in the actual design, I wrote somehow, unfortunately or mistakenly, accidentally or intentionally, A minus B. And in my intentions, I said that A has to be positive number, B has to be positive number, and the result has to be A plus B. Now, if I start testing, they will give me different answers. They are not able to detect the exact cause of the error. And now this tool has given me an opportunity to exactly tell me that, look, guy, either the way you are doing the job is incorrect, as you can see, it has pointed an error, or what you are trying to do is something different. So there is something inconsistent with what you are thinking here and what you are actually doing here. And it has really given me an opportunity to think, oh, what do I really want to do? Am I really looking for an addition, or I really want to do it in a different way? And now, if I want to fix it, I have to fix either of them, because either I'm thinking wrong or I'm doing wrong. And now, if I go back, I can fix it either way, or I can fix it here and I can say, okay, whatever I call it, I'm actually talking about the subtraction, and now you see everything is okay. Or I can go back and I can say, no, you are right, I was thinking wrong. Actually, I need to add these two numbers, and now it should have, again, no complaint. You see. So it is really an opportunity to ask you questions which are very weird about your design. And until you really satisfy this stupid machine, which is computer, you will not get a good result. And this is an opportunity where you can really certify your design, your program, which have no errors, because you will have at the end a mathematical proof why a certain specific program is correct, or how does it actually work. And now, if I mean, going back to some other tools, let me show you a more interesting tool, which actually does the job in a very interesting way. So here is a simple program written in some language which is more of functional, as you see. Probably you are not familiar with the syntax, but don't worry. It is addition, division of two numbers, A and B. And I've started computing remainder and quotient, and eventually returning some result. And here is the testing where we said that, okay, can you please tell me the result of dividing 1000 by 10? Now, if I run this program, you will eventually see that the result is 100. Dividing 1000 with 10 is the 100 answer, right? So that's true. But can I know really that whatever the input I will give it to the system, it will give me the correct result? There is no answer. In order to get that answer, we ask this tool to make sure, can you please prove or show me that it really does the job as we intend? And now, if I run it here, you see that it gives everything as a warning, which means that no, I cannot prove anything about this program. And now I look at this module of the division, and this is its implementation, as you can see. And I ask him, can you please split and prove some help? It says no. The first question it asks me, oh, you see, I even don't know whether your program terminates because it has a loop in it. And with this loop, I am not sure even if the program terminates for all the possible inputs. And now I have to show it. So I cannot see that the program terminates. First, show me that your program terminates. And then I will tell you that the result, what it computes, is the result what you desired. And in order to do that, we add some specification, which means that I say, okay, look, I can tell you some more details. And the details are the following. I ask A to be positive number, but B strictly to be greater than 0, because we know that dividing by 0 has an exception. Zero division is an exception. It cannot divide. And now I ask, can you please now go back and see if you can tell me something? Now it gives me again 2 questions, and he says that still I cannot make sure that your program terminates. And at the same time, I cannot tell you whether the result which you are looking for is the result which it will compute from here. So the result I'm asking him is that if you divide these 2 numbers, at the end, if you multiply the result with the B and add the remainder, you will get the answer A. The typical multiplication way of dividing. And the remainder should always be a positive number, but less than the divisor. Now I start adding, and I say that, okay, look, I can tell you that why does my program terminate? And I add here something which is called variant. I will not explain the further details because we do not have enough time, but here the idea is that you tell him why your program terminates. You really need to show an expression which in each iteration of the loop decreases and eventually it terminates at 0, because otherwise you cannot be sure that whether your program will terminate. So now if I ask him, it still tells me, okay, yes, I guarantee that the loop decreases, the loop variant decreases, and it means that the termination is okay, but still I'm not sure about your result because I don't know what it is computing in the loop, because the loop unfortunately can be executed 1 time, it can be executed 0 time, or it may not be executed at all, depending on the output, right? So in this sense, we then provide him a very strong relationship of what is happening within the body of the loop in this condition invariant. And now we are telling him that whatever you compute here, the remainder will always be greater than 0. And here will be the relationship of the other variables. So we are telling him that what will be happening within the body of the loop. And now when I ask him that, now can you please show me everything? Yes, it does show everything. And the good luck part is that if, for example, I remove something, for example, I make some error here, and I ask him, can you please now show me? And it says, okay, I can make sure that the termination is happening. Here you see. But unfortunately, I cannot tell you that the result is the same and whether the invariants are hold at the start of the program. And the good luck is, or more probably informative part is, that when I click on that condition, it highlights the corresponding part in the program, which means that it actually tells me that what are the concrete parts where my error can be. And now I can go back and I can fix, because either my thinking is wrong, which means the specification part, or my implementation is wrong, my design itself is wrong. And whatever I come up with, I eventually can go back and fix it. And now I have a proof. And if you just go back, you will see eventually that for all this part, here is the backend mathematics written. So here is the whole bunch of a mathematical theorem which is written, which is a proof, which works that why this program actually computes the division of the two numbers and will always give you the result which is desired. And now this mathematical proof is a certificate which you can give it to anybody in the world, not only the mathematicians, but anyone, and can tell them, look, this is my proof, go and find the error and tell me that if it doesn't work. Otherwise, this is my certificate. So with this, I will move on to the remaining part of the presentation and concluding it in probably next few minutes. So based on the same approach, we have developed several systems. One of the system is that it actually detects security attacks at runtime. The system is very complex, but in principle, it has the implementation, the software running inside, and some description written what it is supposed to do. At runtime, it collects the data from the system and compares. If something goes wrong, it raises the alarm, it suspends the system execution and start diagnosis. But as it knows what the system is supposed to do, it actually can diagnose the exact reason what has gone wrong or what has been compromised. And then it already starts recovering the system automatically. So we have deployed this system mostly in the nuclear power plants in New York. And we have also run this system for the monitoring of the Airbuses for aeroplanes, because whenever there is some violation, it immediately detects and tells us that something has gone wrong. However, in this presentation, I will show a very simple demonstration, which is the water tank. You see here, there is a water tank which has some water in it, which has a certain height. There is a pump, which is an embedded system, which we have heard from the previous speaker. So this pump is actually pumping the water within the tank to achieve a certain height. There is a sensor which you see with an eye, which is telling me that what is the current height of the water in the tank. And now there is also an attacker which is also looking at it, and he may compromise the system in several ways. He can change the sensor values, he can change the controller. Probably the guy who is operating the system, he himself can be compromised and he decides to kill the system. So think about it, that there is a pilot running, flying an aeroplane, and he decides to kill his life, but on the board, he will kill not only himself, but 400 people on board. And we want to avoid it. Even if he wants to do something wrong, system should stop him. And this system exactly does the job. That's why we have already the system running with Airbuses. And now, just to show you the demonstration, let me run a simulation of it, because it requires a licensed software to run, which we cannot run at home. So we have prepared a small movie. So let me show you. Can you see already the screen?
Yes, it is visible.
Right, it is visible. So here on the left side of the panel, there are different parameters which we can set, that how much height we want in the water tank and what are different parameters. But on the right side, you see here the simulation results, and this will show you that how the simulation actually works. So we will have the two modes. First, we will run it without our system, that, okay, you have a simple program without our tool, ARMIT, and we will see that we will not be able to detect any threat or any error. But then we will enable our tool to monitor its execution, and we will see how quickly can it detect the threats or violation. So here is the first mode. As you can see, the simulation starts with some value, whatever it is. As you see, yes, it filled with some value. Some tank has been filled. And now we start generating error. We have started giving him wrong values. So you see just some, forget about what we are doing, but we are giving him some wrong values. And now we are asking, can you please simulate it again? You see it has started overflowing and system has been unable to detect. So it overflew, the water has been started coming out of the tank and the system couldn't detect it. And now we are interested to detect it with our system, and you see it immediately detected, and here it showed that, okay, look guy, here is the error. I was expecting something different and you had something different. And now again, you see we disable first our monitoring and we start like corrupting the controller itself. So like Stuxnet, there was an attack where people were able to control the controller. You still see it is going to overflow. Nobody detected, everything gone. And now we enable our system, which is ARMIT. And now we are going to again simulate it. As soon as it went up the 5, immediately it detected the error and told you that, look, this is the error. As you see that this has been modified and this is the reason. This was the expected value and this was the actual value. On the right side of the panel, just below the graph, you can see the system status. It actually tells you that this is what I was expecting and this is what I received and this is the contradiction. So I immediately get an error. So this was a small demonstration. With this, we have actually detected the bugs and errors with more serious systems like the nuclear power plants, as I mentioned, in some Airbuses. And it does not only detect these computational attacks, but it also detects the communication and false data injection attacks, where people can give the wrong values to the system for any reason, and it still manages to detect it. More interestingly, it has managed to detect, force the system to detect the insider attacks, where somebody from within the system decides to cheat the system. He is unable to do that. And a particular case was, as I mentioned to you, was the Airbus, that even if the pilots wants to do something accidentally or intentionally, anything can happen. The system covers both cases and it can detect the errors. Just to give you some insights of what is going on in the globe recently in this direction. So more recently, like 5 years ago, first certified compiler has been developed in this direction. So the CompCert is the certified compiler for C programs, which means that you can be sure that your compiled program exactly contains the same meaning as it was written in the C program. You know that compiler does several optimizations and it translates your source language into a target language, but you don't know what has happened in the middle of the way. And you really want to make sure that the actual translation from the source language to the target is actually the one where you desired, and nothing has been changed. So this is the first compiler in the history which does the job. And more recently, there has been a new project. I was also part of that when I was a postdoc at MIT. The project actually started back in 2016, and it is going to finish in 2021. This is a very big project, deep spec, with the joint effort of academia, very premier institutes like MIT, UPenn, Yale, Princeton, and also the industry, the software industry and hardware industry like Microsoft, Facebook, Google, and also the hardware part from Intel. And they are focused to transform the current software engineering way of thinking, developing the system, where we have the interfaces. You see, we have module implementation and we have input-output interfaces to a new paradigm, which is called software verification, where they really want to say that interfaces are described as specifications and the module implementation has actually a proof of its correctness. So you do not have just the interfaces, but you really have their description with it so that people really can see what it is doing. And with the proof, they know why it is doing. So they really believe in the reason, because you probably look, it could be possible that you want to be rich. Okay, that is your goal. But of course, you don't want to be rich by stealing the money, right? You want to be rich by doing some respectable business. And this is exactly why this new transformation is helpful. it does not only tell you that what it is doing, but it will tell you that why it is doing and how it is doing. And that is exactly going to make you understand, as previous speakers have also highlighted, that they are looking for developing the solutions where really they can understand why system is doing a certain execution or certain behavior. Here we really want to make sure, and this really does the job. Before I terminate my presentation, I just want to give you a highlight of our recent project, which is actually this one. So let me, yes. This is the recent project where we are really doing, combining this tool with more machine learning one. This is a very mega project, as I told you, and I'm PI and the technical lead of the project. We have 22 partners across the Europe, and they involve Amazon and MasterCard and all of these big giants who are working in the e-commerce sector. So the idea is that you have web applications running, but how can you really make sure that they are doing a job good? I mean, like, you are buying something on online, sometimes you get a physical delivery of the item, sometimes you get an email for online interaction, sometimes you get just a virtual number. Okay, this is the number and you can use it for your voucher. How can I make sure that all those things are real and they are really not compromised? And here you see this big part is the detection part is really the one where our monitors, and all of these monitors are based on the tool which I've just shown you, and they are integrated with machine learning based detection tools, so that we can make sure that the machine learning does not produce false alarm. Because typically what happens now is that machine learning comes up with some false alarm. They can detect something, but they, first of all, they don't know what they have detected. They simply tell you this is what I detected, and at the same time they give you some false results. So we really want to make sure that there is no false alarm, because we are usually detecting and monitoring the security of the critical system, which are more critical, like in air buses and nuclear power plants, where there is no chance of error. So that's why we are combining these two to detect the errors and detect the threats more rigorously. I will not go into the further details because of the lack of time, but I just wanted to give you an idea. And with that, I thank everyone for listening. I'm happy to take questions. Otherwise, feel free to contact me on my email. I have provided my contact already on the very first slide. And here is my website. You can visit. You can look into current activities, current projects, my research interests. And if you are interested in doing anything related to reliability of your design, system, software, their security, safety, privacy, reliability, resilience, come back to me. I'm sure I will be able to help you one way or the other.
Thank you so much.
So if you have any question, please.
Any questions from the audience? Thank you so much.
I'm not sure that I did everything wonderful so that everybody understands everything. I'm sure there will be questions, but whenever you have a question, whenever you see some chance of collaboration or talking to me, please write me.
Dr. Jana, would you like to ask something?
May I ask?
Yes, sure, yes.
Well, I mean, since personally I'm dealing more with machine learning and self-computing, etc. What were the main challenges that you have faced in terms of machine learning in applying these concepts?
Of course, the first challenge was that machine learning current implementations, they tell you simple pattern which they have detected, but they do not provide you any meta information about it. for example, which process is involved in producing this pattern, so that we can really understand that, because we are interested in understanding that, not only detecting that somebody tells me, oh, you are doing bad. I'm interested to know what I'm doing bad and how can I fix that. So here, the machine learning systems were only able to tell me that, look, I can tell you that this is the pattern and this pattern is different than others. It may be good or it may be false. You go and check it. So what we did is we took those patterns and we associated those inputs with the corresponding processes from which those data was generated. And now, as I have the specification of those parts or processes, I was able to see whether that particular input, which the system, the machine learning system has told me that this is something unusual, does this input satisfy my specification? If that satisfies, that means that this was a false alarm. Everything is fine. If that violates my specification, I can immediately see what is exactly the main condition which has been violated. So this was the challenging part, that we had to connect the feedback from the machine learning system to the actual processes through which that feedback has been generated. Because we are working, I'm sure you know it very well because you are also working in Industry 4, right? So in the embedded system, we have this opportunity that we know the process, we know the exact process through which the data has been generated. When we are talking about the plants, we are talking about the components, controller, we exactly know what this component is supposed to do. So here we have a chance to write their concrete specification. So we let the machine learning system work in a way, whatever they do, so we don't really hinder their strength and power. We said, okay, go whatever you want to do and tell me the result. And then with that result, I will consider your result as a first filter. But before I really take any action on your result, I will make sure that you do not produce the false alarm.
Okay.
Yeah. And yes, and the second challenge where we also used the machine learning with our tool was we used our verification techniques to help machine learning to choose an appropriate model. Because currently, you can choose any model while you are computing, and based on your model, you can predict whatever you want. But the first question is, are you really choosing the right model? And here before really choosing the model, we used our tool and we looked at the given data characteristics and find out what is the more suitable model which can best describe this kind of model. So that instead of just giving a rigorous test and getting some statistics, we had a rational and a logical reasoning why you should use this model to predict and to test your train your system.
Okay.
If you are interested, I am co-organizing a workshop which is taking place next week in Vienna, Austria. And this time it is virtual, and we have exactly the same topic, how we can make the machine learning more rigorous for the safety and security of the systems.
Interesting. And by the way, I as far as I can remember, you mentioned that you've been participating in Horizon 2020.
Yes.
For FP7. Which scheme? I mean, was it, I don't know, Factories of Future, or what was the, let's say?
So the theme which I participate is the security of critical infrastructure.
Okay.
Yeah, this is directly related to embedded system,
Okay.
Yeah, embedded system, industrial control system, cyber physical system. So that's exactly where do I work.
Okay, since I'm dealing frequently with European Commission as assisting as an expert and advisor for monitoring the funded projects. So I've been just interested, which is the area that you have.
Yeah, it's the critical infrastructure security. So last time it was on security, and this time we submitted two proposal for privacy of the personal citizen.
Okay.
Yes.
Okay, okay. Thank you. Thank you.
Thank you. Thank you.
Thank you
So
so much.
looking forward.
Imran.
If anyone else has any question.
Thank you so much, Dr. Taimur Khan, University, Greenwich University, London. Now here is a lunch break, and thank you so much. We will start our next section after 30 minutes, and hope all participants will get that. Thank you so much.
Okay. Thank you.
Thank you.
Thank you.